It's kind of a reunion. A lot of this started when you and I were working together back in Cambridge back in, what was that, 2015? Something around there?
God, probably when we were
Probably
both
about a decade ago.
young and more optimistic. Welcome back to another episode of Demystifying Cosmetics. I've titled this one, What We Know and What We Don't Know About the Microbiome, with, of course, our favorite Dr. Larry Weiss. We were joking beforehand that this title is a work in progress and actually should likely be what we think we know and what we don't. But on today's episode, I want to walk through a paper that was published in July of 2025 in Nature Communications regarding some of the work that you have done in evaluating rural population skin microbiome, specifically that of the Yanomami tribe in the Amazonian area. Remind me again of which country, because I always forget.
It's actually in Venezuela.
Oh, okay. But the title of the paper, which is very compelling, is the Yanomami Skin Microbiome Complexity Challenges Prevailing Concept of Healthy Skin. And we've obviously had guests on previously talking about the microbiome, more in the sense of ways to potentially formulate or ways that currently products are tested for that quote unquote microbiome safe. I know you and I touched upon reading the same article this morning from Cosmetics and Toiletry, indicating that Spate, which is a market AI intelligent platform that looks at trends, has indicated that 120.1 year-over-year growth for quote unquote skin microbiome. But as you called yourself a pathologically optimistic cynic, I think you are a great guest to kind of walk through what we know or what we're learning and what prevailing concepts, specifically from the paper, you feel are challenged now, and then ways that the industry as a whole can take these ideas or even the foundation for which you approach problem solving to advance the concept of the skin microbiome and how it can help us as a whole, health-wise, population, all of those great things.
Well, thanks very much for inviting me, and it's kind of a reunion. A lot of this started when you and I were working together back in Cambridge back in, what was that, 2015? Something around there?
God, probably when we were
probably
both
about a decade ago.
Young and more optimistic.
Well, a little less seasoned. How about that?
Okay, that's true. That's fair.
Okay. And look, I think that before we go into the depth of this, there's something that I would like to put out there, which is there is a common misconception in the public and also within the sciences that what we work on, what we strive for, are immutable facts in capital T truths. But if we're honest, that's not really correct. What we do is we make a model of something we don't understand, and we use the best tools that are available to us to test the hypotheses in the model, and we get some more information, data, evidence, and if we're honest, we take that and we fix the model, and then we keep doing this, and we go around and around and hopefully learn more and more. But it's the day that we believe that we have an immutable fact or a truth that we blind ourselves to that piece of information that is going to come in and challenge that truth. And it's mostly unknown. I quoted Popper before, our knowledge is finite and our ignorance is infinite, and it's especially as it concerns the microbiome. Look, microbiology, when I was younger, was almost a dead sport in the sciences. No one really wanted to do it. It was used in clinical medicine. And, when I got out to Stanford in 1977, one of the neurobiologists spoke to us, shiny-faced incoming medical students, and said, "We've conquered infectious disease, and cancer and heart disease are your regeneration's challenge." And then, HIV and all sorts of things came along and gave us a little bit of humility. But what ended up happening is, because we were able to sequence DNA, we started the Human Genome Project. We pointed this technology at our favorite subject, us.
Ourselves, yeah.
And what we discovered right around 2000 was a whole lot of us wasn't us. And that gave us a window into microbiology that we never had before, because it was a purely observational thing before. Now we actually had data. And this changed everything about the way we see it. So we're standing on the threshold of what is truly a scientific revolution.
Yeah.
And when we started working together, this was at AOBiome, the hypothesis was there were bacteria that were part of our physiology throughout most of our evolution. And when we lost that, that had consequences on our health. Now, if you want to test that proposition, all you need to do is you just need to find a group of hunter-gatherers who still live a traditional lifestyle and fully sequence their microbiome. That was very easy to say, but not so easy to do. And in the course of what we were doing there, I became introduced to a young man whose father was an American anthropologist in the 70s and 80s, and his mother was one of his subjects of study. And he went down to study, they're called the Yanomami. A book had come out by a guy named Napoleon Chagnon, the book was called Yanomami, the Fierce People. And Ken Good, this anthropologist, as a graduate student, his job was to find out why they were so fierce. So we wandered into the jungle and found an uncontacted tribe and built a relationship with them. And it was supposed to be a 9-month graduate program ballooned into an 11-year odyssey, during which the head man betrothed his sister to him, and he married her. You can imagine the firestorm that created. The oldest child of this, David Good, I one morning was listening to NPR on Snap Judgment, and I heard that.
Nice.
And he had described this, and he hadn't seen his mother in over 20 years. And he was trying to raise some money for an expedition to go down there. And I reached out and said, hey, David, if you're going down there, could you do some swabs for us?
I did not know that. I did not know the story. I didn't know how you got connected to David, but this is very funny that it was through an NPR episode.
And we developed a relationship, and that didn't work out for reasons that are irrelevant at this point. And then in 2017, he called me up and said, how would you like to collaborate to study the microbiome of my family? This is his family. There's only one correct answer to that. And that started a 7-year research project. 3 expeditions. And the thing that makes the Yanomami interesting, and hunter-gatherers who still live a traditional lifestyle interesting, is they don't have any inflammatory disease at all.
Yeah.
Things on the skin like acne, eczema, rosacea, and psoriasis do not exist in these populations at all. Coronary artery calcification scores in their 70s and 80s are better than ours in our teens. They don't sunburn. That's not a melanin issue. Dark-skinned people can sunburn too. I do it better than they do, but they can do it too, and they can get skin cancer, and they don't get skin cancer. In fact, as far as we know, they don't get cancer.
Yeah.
Their modal age of death is about the same as ours, mid-70s, but we need 15,000 pharmaceuticals to get there, and they need none. And so 500 DNA, RNA samples from the skin, the gut, every HMP site over 3 expeditions, and almost 200 live culture samples later.
Yeah.
What we found, and we published on the skin, is that in terms of taxonomy, we've lost about 80% of the taxon on our skin. Then we interrogated it functionally, and in terms of function, 25% of the metabolic pathways they have are gone. Now, one of the parts of the study that's in there is we tracked David's microbiome from before he left, when he was down there, and when he came back. And when he's down there with his family, he lives a traditional lifestyle. The only thing he really does different than them is he wears shoes because their feet,
are calloused and able to. Yeah.
And running through the jungle in bare feet in our feet is not a proposition. Within 2 weeks of being in his mother's village, the diversity of the skin microbiome looked very much like his family's. And then we brought him back in 3 days, which, considering how difficult it is to get to this place in and out, this was epic.
Yeah.
No soap, no shampoo, no shower, no change of clothes. We got him right into the lab 3 days later, and he looked like he did before he left.
Yeah.
So I used to think the loss of diversity was because we washed it away, but that's not it. It's because we're harmonized with the environment in which we live.
Yes. Yeah.
We live in a built environment, one of the most diminished microbiome environments on the planet, and they live literally in nature, which is how we as a species spent most of the time. When we looked at the function that was lost, there were two huge clusters of genes that were missing. One of which was around redox, oxidative protection, essentially rust proofing. We live in an oxygen environment. We're bathed in ultraviolet. Oxygen, water, and ultraviolet will always make superoxide.
Yeah.
High energy, free radical, basically electrons. Bacteria solved this problem 2.7 billion years ago, or we wouldn't have them around now.
Yeah.
They're pretty exposed. And the way they did that is the cascade of electrons down, their biology is it does constructive work on the way down. And by the time it reaches our tissue, it triggers things. It's at a level of energy that triggers things that we need done. The other big cluster of genes were secondary metabolic pathways, many of which make things that we need and don't make for ourselves. And one of the examples that they had a yeast on their skin. It makes retinoids. Not just the retinoids that you and I think about, retinol, retinol, and retinoic acid, but a whole family of them, because retinoids are made by, you take a C40 carotenoid, these colored things, and there's an enzyme that cuts it in half, and when it does, it makes a retinoid, and some of them are agonists, and some of them are antagonists, and some are mixed. What we do is we make the most potent one we can, we put it on the skin, and when we do that, what it tends to do is that node is now insensitive. It's no longer regulatory. It is locked in it's pinned to its hive. So it no longer responds to the stimulus around the networks that it's connected. In the biologic metaphor, this mixture can never get to that limit. It becomes sort of a molecular vernier. It has much finer control. And that is kind of how this biology works. What we lost on our skin, we looked at the data for 2 years before we realized this, because the nose on your face is the easiest thing to miss. It was a biofilm. They have a healthy environmental biofilm. And when I tell you that, it's obvious. Of course they do, right? Biofilms are everywhere. And so their biofilm harmonizes them with their environment. They live in nature. That's what we did for most of the time we've been a species. Call it, 98% of, if we were around for 500,000 years, probably we did that for, maybe the last 20 to 40,000 years. We developed agriculture, we could live in greater population density, and the transition started at that point. But we don't have that biofilm anymore. So we don't have that protection from oxidation, from rusting. So we're all rusting. Okay. And just oxidation and inflammation are two different perspectives on the same process. So the chemist in me looks at it and says, if you don't start thinking about electrons as metabolites, it's not going to make any sense to you. And the immunologist in me says, we're looking at inflammation. Look at all these inflammatory pathways. But it is all of a piece. And this is the point where I say that, again, our knowledge is finite, our ignorance is infinite. This is such an incredibly complicated system that none of us are entitled to any certainty. And it's still very, very early, and there's still a lot of work to do. But the promise of this is a scientific revolution which will transform everything. And the life sciences today is where physics was 100 years ago. Okay. And you can imagine these classical physicists with their buttoned up equations, watching Einstein and this oncoming chaos and just dismissing it as either being wrong or irrelevant. Yeah. They even wrote a book. And the book was 100 authors against Einstein, to which he responded, if I'm wrong, why would you need more than one? Okay. But this is really exciting. This is a huge opportunity. This is a breakthrough. It's just that when these things happen, it tends to be fairly chaotic. And so science is a disciplined practice of wonder. I'm going to emphasize the discipline and the wonder, but what it means is we need to have a deep sense of humility. That when we see something and we learn it, we're just getting started. And there's not going to be any certainty. So the excitement around what's going on for the microbiome is real, and it's important. But, what we actually know we're still very much in the hypothesis generation phase. And this excitement should lead ourselves to try to learn more and find ways to apply it. But what we built with the Yanomami is an evolutionary reference point.
Yeah.
We now know what it looked like when everything was working.
Yeah.
We don't have to understand all of the connections. We now have a chance to do something we could never do before. Everything that we've done before, and everything I trained to do in medicine, is we fix broken stuff, right? You come in, we do some tests, we figure out what's broken. We poke around in the mechanism of a disease that we don't really understand and find ways to introduce a novel, patentable foreign substance to ameliorate the symptoms of this thing that we don't understand. And along the way, we always break some more stuff. We have with this reference point, we have the opportunity to do something we couldn't do before, which is to try to restore what was lost.
Okay, real quick. Raise your hand if you have dealt with active instability. If you have ever opened a jar of retinol cream and smelt an off odor, or noticed your formula went dark brown, chances are you are dealing with active instability. It's never fun when the formula you've been working on goes south and the due date is only days away. That's why we've encapsulated the trickier ingredients to work with so you can kick the stability struggle to the curb. From retinol to vitamin C, we make it easier to work with those ingredients that typically give you that 3 p.m. headache. The cellulose shell shields the active from outside exposure. Things like air and light that are likely to cause active breakdown, giving you the power to create stable and effective formulas without the trial and error. Ready to quickly create effective skincare formulas? Discover Tagra's CelluCaps line by going to tagra.com/CelluCaps. So, have you encapsulated yet? Now back to the show.
And so I'm very curious to hear about what you think your hypothesis is for how to restore this. Because, right, we can't just all pick up and live an agrarian lifestyle. A lot of us can't, remove the exposure, environmental exposure that we're within, right? That's geographic regions and mobility and how, even just our homes, right? Architecture-wise, creating areas of outdoor exposure, are very difficult things to do. And so I know you and I were talking before, and, you mentioned what keeps you going is that, you have grandkids. And so this prospect of making things better for a future generation, what are these kind of things that you think are actionable, but in terms of 100 years, because I don't think we can get there within our lifetime, to be fair.
Right. It's a process, and it takes time, and we need to have that sort of sense of humility and patience. But it's the right question, because we're getting sicker. The incidence of inflammatory disease has tripled in the past 30 years. 1 in 4 kids now has eczema. In some places, it's even higher. If you follow the kid for 5 years, 90% are carrying an inhaler. They have 1 or more food allergies, and 1 in 30 is in the spectrum. And I will stipulate that we've expanded the diagnostic criteria for these, but that doesn't account for all of it. And so the incentive to do this is strong. We are raising the first generation of children who are likely to live shorter, sicker lives than their parents. And we deserve better. So we need to try to understand this. Now, one of the things I'm pretty certain of is we cannot put back the microbiome that we lost, because time's arrow only goes in one direction. And the way that we live today, we would have to live in nature to try to do that. And I don't see a way to do that. But what we have come to is this. See, what we lost on our skin is a biofilm. And that biofilm harmonized us with that environment. And in any given environment, the taxonomy of that biofilm is going to be specific to that biome. There's an almost infinite number of taxonomic solutions to the physiologic output, because there's a lot of commonality in biology.
Yeah.
And bacteria tend to be generalists.
Yes.
So whether it was the Yanomami in Venezuela or, a tribe in New Guinea, they'll have a different taxonomy, but they will have very similar outputs from that biofilm.
Yeah.
But the biofilm on us is very similar to the biofilm on the plants. So you sustainably harvest some plants from that environment, and then you allow them to ferment, to express these gene clusters.
Yeah.
And those fermentations can take anywhere from a couple of weeks to a couple of months. And then because the skin is a lipophilic and an oily environment, what you do is you take that ferment and you centrifuge off the oil. And the complexity of this stuff is mind-boggling.
Ferments can be made. I don't know if people know that when you see something that's like, genus, species, ferment, it can be derived of 50,000 plus compounds that we don't even have analytical standards for. We can give you a close proxy of what it might be.
That's right. And if you put one of these things in untargeted mass spec, the metaphor I use for this is NASA did a thing called the Deep Field Experiment, where they pointed the Hubble at the darkest piece of space that they could find. And after a year and a half, what they found in that dark piece of space was 10,000 galaxies.
Yeah.
Okay. At a molecular level, this is the expression of biology that in some cases is billions of years old. And each one of these ferments, and we have a lot of them, what we believe, and again, this is still hypothetical, is there's a substantial portion of that is common to all of them, because that is the currency of an aerobic ferment or an anaerobic ferment. That is the basic biology. And then it has personality on top of that. That is a function of the specific taxa in that environment. And so the experiment you do is you take this and you formulate that into topicals, skincare, things that people are familiar with. And then, and this is the important part, you have to validate it. And you say, if I put back this part that was lost, what do I see? Because this is very different from the administration of a novel, patentable foreign substance, generally a single molecule, because pharma is much happier with single molecules. One of the things they do not like about the microbiome
is the unknowns.
they there's a thing called the CMC, the chemical material control, and if you're developing a drug, that is the drug.
Oh yeah.
Okay. Now they like a molecule. They definitely don't like a bacteria or a consortium of bacteria, and they absolutely don't like liquid shit. So they don't like any of that kind of stuff, but this is the output of an ecosystem that we lost. So if you put it back, what do you see? And so this is very different from treating disease. It's restoring health. But if we're going to talk about health, we better define that word so we're talking about
I was going to say, when, traditionally, right, in past guests or what you've seen in the industry as a whole is you put it on and you test it, right? And you're doing the sequencing and saying, what's the diversity? Is it higher? How did it shift? Without knowing what degree of shift equals degree of health. Or unculturable bacteria or fungus is on there. What metabolites are they producing? So, when we talk about health, what are the things that, you think we should be looking at when something is applied to the skin to understand if we are shifting anything?
So the way that we understand as society health is not being sick, that we know about. Okay? That's not health, that's non-sick. Let's be clear.
Yeah.
Health is an evolutionary property of a species that has been optimized over a long period of time. And basically the way I think of it is health is the resilience in response to stress. They bend, we break. So when we are stressed, we break, and that triggers some sort of inflammatory process. But again, remember, this is all systemic. If you see inflammation on the skin, you can be pretty sure you're systemically inflamed. So when we talk about health today, it's just not being sick. And I want to recast that as non-sick. This population I'm going to use as a model for one example, and it's only one, but there aren't very many of them left, and you cannot just show up in one of these villages and start doing science on it. And so the way that I think about this right now is how do we rebuild that resilience? Because that resilience is the underpinning for health. And if we have to do it because we understand the mechanism of action, we are so far away from that. Even to our methods, let's talk about this for a second. Our methods to study the microbiome, sequencing, have all sorts of biases built into them, and we don't really have a gold standard on it. For the longest time, even within a single lab analyzing the same sample, we would get different results. We're now better at that, but it's still very early and it's still very imperfect. So we have to be very careful how we interpret this. And I've heard recently someone say, well, we'll fix this with artificial intelligence. Oh, really? We're going to put imperfect data into artificial intelligence?
I was just going to say, artificial intelligence relies on the previous data. So
we're going to train it on data that's flawed and and we're going to chase our tails. So there's still a fair bit of work to do with this. I would say that now we're reasonably reproducible, which is precision, but we're not accurate. So we are precisely inaccurate with our data. So there's that first point. The second thing is the complexity of this. We have a tendency, we see a couple of points in a row to draw a line through it, but there's a lot more points we don't know.
Yeah.
And I'm going to try something out on you.
And it's also, I think of causation and correlation, right?
So that's such a setup for me, because that's what I was going to do. So probably everyone listening and has at one point either said or heard someone say that correlation doesn't imply causation, right?
Yeah.
And that's fair enough, except if there was no correlation, you wouldn't go looking for causation, would you?
Fair, yeah.
Okay. And if you go looking for it, you don't find it. Does that mean it's not there? No, of course not. You just didn't find it. Okay. What if you go looking for it and you find it everywhere? Remember, you and I worked on nitric oxide. You want causation? You tell me when you had enough, because it will go on forever.
Yeah.
And the problem with that is it sets up a logical bottleneck. It only will let you see highly coupled linear processes. But biology tends to stay away from those because those are setups for significant failure modes. Anywhere along the line this fails, the whole thing falls apart. Biologic processes are systems with all kinds of complexity baked into them. And so when we set up that logical bottleneck, what happens is it doesn't work well in systems biology. It works very well for Newtonian approach, nice linear processes tightly coupled, but in a highly complex system like us, which brings me to something else that's worth discussing here. When people ask, what is the microbiome? And we tell them, oh, these are all the bugs that live on you and in you, that is wholly unsatisfying for most people. And I think it's for three reasons. The first one, you're asking them to believe in this highly complex, invisible force that is important in their life, and that sounds like the purview of religion. The second thing is, people already have an adversarial relationship with the microbial world. That's kind of hard to get around.
To be like, no, some are good. Some are good. You just can't tell which ones.
And then they go off to ChatGPT or Dr. Google and they come away completely confused. But that's actually the appropriate response because it's still too early, which is why, the way that I'm thinking about this is, if we have to take the science that only admitted that a microbiome existed 20 years ago and say we're far enough along to be able to interrogate that data as we understand it and come up with solutions to what's going on here, well, that's going to take too long.
Yeah.
Instead, we built a reference point. This is what it looked like when these problems, and I don't have to understand everything that's in here.
Yeah.
What I need to be able to do is do the experiment of, is this safe enough to do the experiment? And most of these things very much are. And then, is there a way of looking for a clinical signal in that? And then following where those signals take us. And this is going to change, this revolution is going to change everything.
Yeah.
But, and here's the mistake. Do not mistake a clear view for a short distance.
Yeah. Yes, I know. I think I just said, I don't think the progress that we are hoping to make will happen in our lifetime. Something I also want to quickly touch upon, which you briefly mentioned, that one of the fallacies, or not fallacies, but I'll say, ways of thinking that changed with the study of the Yanomami was that the models that we're using now to study disease states is flawed, right? We are using, and I've touched upon this, the repository of strains that we generally take from, right? ATCC, whatever those biorepository are generally acquired from white, industrialized
human,
right?
Homo sapiens, yes.
So you just a narrow, very narrow view.
And severely diminished.
Yeah.
And severely diminished, right?
Yeah.
Okay. Here's a crazy thing that we learned. So the piece that we lost 80% of the taxonomy. That was a healthy environmental biofilm that harmonized us with the environment. Underneath that, we got a chance to look at one, Yanomami, David's mother, who took a shower. So we got a chance to see what her engrafted microbiome, not the biofilm, but the engrafted microbiome looked like. You know what it looked like? Looked like ours. Genus level, yes.
Yeah.
Species level, significantly. They live in one of the most diverse microbial ecologies left on the planet. We live in the most diminished, and yet the engrafted microbiome looks a lot alike. And the way I interpret this is that those relationships are biologically programmed. So what we talked about is the biofilm has a bunch of function. It is the antioxidant, the redox, the rust proofing. It is a source of all sorts of biomolecules, many of which we need and don't make for ourselves. The engrafted piece has a lot of functions, but it has two very big ones. And the first one, you and I know, is colonization resistance.
Yeah.
And the way that I explain this is, this means you keep that ecosystem so well populated with the organisms that are so well adapted that an outsider has a very hard time getting a foothold.
Yes, engraftment, we've seen in introductions of probiotics, is very difficult.
Truly, so far, I have not convinced that anyone has achieved true engraftment. There's been some persistence, but ultimately it gets kicked out. The second big job is it communicates directly with our immune system and is able to mobilize and demobilize an immune response under the appropriate circumstances.
Yeah.
Well, those things you would expect to be programmed. The biology, we co-evolved with those. And all we have left is the engrafted piece. Want to know why 70% of women report sensitive skin? Because the protective layer is no longer there. And what we think we can do is whatever the latest buzzy cosmetic ingredient is going to fix that. Wouldn't that be nice? It's going to be more complicated. So the approach that we're doing here is to continue to take these ferments, and we have a lot of them, and look to see what type of clinical signal we can do in a large-scale, substantial study, and use those signals to follow this, because one, inflammation is systemic.
Yeah.
If you want to just make an assumption, assume you are inflamed in your gut. Here's a really interesting example. Hunter-gatherers get about 3 to 5 grams of polyphenols in their diet every day. You and I live in places where we can get fresh fruit and produce every day of the year, and if we work at it really hard, we can get a gram. And polyphenols and that whole group of molecules are nature's anti-inflammatory. These moderate that flow of electrons. They provide the electron pathways, so it does constructive work. And when you'll hear someone say, yeah, but they're not well absorbed, they're not supposed to be absorbed. We feed our microbiome feeds us. This provides that molecular buffering. And it's, by the way, the things that we eat that go right in that tend to be the biggest problem. I give you alcohol, sugar, things like that. It's supposed to go through this microbial ecosystem before it's processed and delivered to us. And we're only starting to begin to understand how all of that works. But the complexity of this is such that it's not going to surrender to simple solutions. And there is a lot of work to do. And I just caution everybody, be optimistic, but also be skeptical. And the way that we build companies that put products into these markets, whether it's at the pharmaceutical level, the supplement level, or pretty much anything else, we're solving for incomes, not outcomes.
Yeah.
And we deserve better, because our children, we're, as I said, raising the first generation of children who are going to live shorter, sicker lives than their parents. Not acceptable. And doing it for economic reasons, that's even more unacceptable. And what we were talking about before is here's where my pathologic optimism comes from. Our economy is driven by consumers buying products.
Yes.
80% of those decisions are made by Mama Bear. Mama Bear is seeing things going on with Baby Bear that are deeply concerning. They're reading labels. 15 years ago, no one read labels. Now they read labels. They're looking for answers. They're looking for information. There was a Rock Health article that came out a couple of months ago, and they reported that women consider themselves to be the chief medical officer of their family. And I used to say that no one believes any of this stuff they read, but it's not really true. They just don't know what to believe anymore. It's impossible to sort this kind of stuff out, and we need to solve for that. But remember, with those buying decisions, you have more power than you think that you do. And if we can somehow remember we are a community, and we will survive as a community or we will die as individuals. And the Yanomami absolutely know this.
Yeah.
This is how they live as a community. For example, the hunter who brings in game eats last.
Yeah.
There is a tradition of generosity such that anyone who asks for something, they give that. And there's an interesting aspect to this that I'm fascinated with because of the movement towards longevity. So one of the questions you didn't ask is if they don't get sick, what do they die of? We evolved as foragers. We're creatures of scarcity. By the way, very good at it. They don't starve. When someone brings in food, you know what they do with it? They eat it. They don't store it, but they're very good. And as a creature of scarcity, at every age, you are either contributing to the survival of the community or you're diminishing it. When Darwin said survival of the fittest, that wasn't about the individual. Sorry, Elon. That was about the survival of the community.
Yeah.
And the contribution you make to the survival of the community is different at different ages. The elders, they are the libraries of the culture. Remember, we have been a pre-literate species until maybe 5,000-6,000 years ago. So they were their traditions. They kept this knowledge that allowed them to survive in that area. There's another really interesting, I'm fascinated by this particular observation. There's 3 species that we know of who have menopause.
Yeah. Killer
Homo
whales.
sapiens, whales, and some elephants, apparently.
Okay.
And that invented something. That's where biology invented something that didn't exist before. And that something enhanced the survival of children, because our children are born, we're a big brain bipedal primate. Children are born with a prolonged period of dependency. And that invented grandma. And grandma had a specific wisdom that grandpa doesn't have.
It's oddly true, because you can read a lot of articles about grandmother killer whales that demonstrate very unique hunting skills based on pods that to the younger generation.
Yeah, and so the way these communities survive as communities. This is the one thing I'm reasonably comfortable that we do know about the microbiome. The thing that I've learned from it is everything is connected.
Yeah.
And those connections are ancient and microbial. I plundered this parable from David Foster Wallace, but it illustrates it. These 2 young fish are swimming along. An older fish comes swimming in the other direction and says, "Hey boys, how's the water?" And they swim along for a little bit, and then one looks at the other and goes, "What the hell's water?" Those 2 little fish are all of us. The water is this ancient global microbial planet of which we are a very recent and rather destructive expression.
Yeah.
And the voice of that older fish is the growing burden of inflammatory disease that is trying to get our attention about what is water.
Yeah.
While there's still a chance to do something about. And it's not going to surrender. Tomorrow is not going to look like today, and it's not going to surrender to the tools and techniques we had before. We are going to need to expand our very concept of who we are and how we are connected, or we don't have a future. But I remain optimistic that it's a crisis that precipitates a transition in a scientific revolution. And in this particular one, the crisis to recognize biology is a complex system. So I think the big message that we learned from this is we're just getting started. We're at the threshold of the threshold of the threshold of understanding. It is important that we keep doing this. I say this right now because our field is kind of in a crisis. We tied our wagon to investment dollars they're investment dollars. They're agnostic to what they invest in as long as it makes them money.
Yeah.
We have to live with the consequences of what those investments create.
Sure.
But they've gone on. They think we need more artificial intelligence. I wonder why they're solving problems we don't have. And we need to emphasize the importance of this, but we also need to hold to the feet to the fire of whether it's companies or anyone else who's trying to sell us simple solutions. It's not going to be simple. It's worth the work, and we deserve it. Our children deserve it, and our grandchildren deserve it as well. And the big message of all of this is we have people who want to do it.
Yeah.
We have scientists who trained their life. They have PhDs. They've dedicated their time because they know that this is important. They want to do it for all of us. And it is our job to make decisions in the market, to facilitate that, to demand that we get the real truth. Stephen Colbert had a word, truthiness. Remember truthiness?
Yes.
Truthiness was things that sounded truthful but weren't.
Yeah.
I have a new word, science-iness.
I call it sciencing. I'm not even joking. Sciencing with a lowercase s.
and look, just, demand it. Don't accept easy answers. Yeah. If something does not sound true, let's build networks of communities dedicated to running it to ground. And let's make the people who are making those decisions remember that it doesn't matter if you're in the 1% or even the 0.1%. Health is a property of a community. And interestingly enough, there's a whole lot of diseases which tend to cluster in that area because of types of behaviors and things that they do. So it's in all of our interest that in the richest society on the planet, we devote enough of that to try to understand the following question. What is health? How are we connected? What is this microbial ecosystem's role? And what can we do to restore as much of what we've lost so that our grandchildren have a future?
Wonderful. Thank you. I'm glad that we got to have this conversation and we could spotlight the humility, but also the work that needs to be done. Give credit where credit deserves, but also be realistic. Thank you for your time.
It was my pleasure. Happy to do it.